This video goes through the solution for Cambridge Exercise 10B question 8. And the question is, and I'll refer to the diagram as I do it, PQ is a diameter of a circle. So you can see PQ going through the center 0. AB is a perpendicular chord cutting at N. So AB is going through the point N at right angles to the diameter. And it says prove that PN is equal in length to the perpendicular from P onto the tangent at A. So I've drawn in my tangent at A. Now we know that a tangent is at right angles to my center. So I'm not sure if I'm going to need that, but we know that that's going to be a right angle there. So the perpendicular from P, and I will change color. So from P to that tangent, so that is that perpendicular there, and we'll label that point X. Okay, and we need to prove that this PN here is equal in length to PX. So we're required to prove that PN is is equal to PN. That's what we're required to prove. So let's set up our question. We let X be the point. Where the perpendicular from P meets the tangent. At A. We also let 0 be the center of the circle. Now, what we're going to have to do to be able to prove those two things are equal, I'd be thinking that we are going to have to deal with the two triangles. So we've got triangle PAX and PAN. Now, if I could show that those two triangles are congruent, I could show that PN equals PX. So what you're trying to do here is think about what is your end goal? Where do you have to end up? So I'd be thinking that what I need to do is prove triangle PAX is congruent to triangle PAN. If I do that, then that leads to PX equaling PN. Okay, so we need a strategy to start off with. Okay, now nothing within those two triangles is going to help me at this point in time. So I'm going to, I do know they have an equal right angle because we know that right angle is there and that right angle is there. So we know it's got the right angles the same, but that's all we know at this point in time. So then we have to think, well, let's go backwards. Where can I go with this? Okay, so I've drawn in AO knowing it's at right angles. If I drew in BO, so I've got AO and BO, I know that that side has to equal that side because they're the radius of the center of the circle. Okay, so that's an option. So if we look at triangle OAN and OBN, so and we're starting there because we have more information. We know that the radiuses are the same, and we know that they've got a right-angled triangle, we also know that that side there is common. So we know just by looking at that those two triangles are congruent. We just need to say that. So OA equals OB because they're radii. Okay, ON is common. It's shared between the two triangles, and angle ONA equals angle ONB, which is 90 degrees. Therefore, triangle OAN is congruent to triangle OBN, and that's because of side, side, side. So if we know that, we therefore know that side AN has to equal side BN. So those two sides are equal. Now I'm trying to get to the two triangles, PAX and PAN. At the moment, I've got BN and I've got AN. So how about we draw in PB? Okay, so join PB. Now let's look at triangle APN and triangle BPN. Okay, we know that AN equals BN because we just proved that. Okay, we also know that PN is common, and we know angle ANP equals angle BNP because they're right angles. So we've got the two sides and the included angle. So therefore, triangle APN is congruent to triangle BPN because of side angle side. Okay, so where do we go from here? If we know that they're congruent triangles, we know that this angle here has to equal that angle there. Okay, because that can lead me to the triangles that I want. So angle PAN equals angle PBN. Oops, should write corresponding sides of corresponding angles of congruent triangles. Okay, so now can we look at the triangles that we want to look at? So I'm running out of room. So let's look at triangle PAX and triangle PAN. So the ones we're trying to prove are congruent. Okay, and this is where the alternate segment theorem comes in. If you look at it, you have got angle PBN. So this angle here has to equal angle PAX. And that's because of that alternate segment theorem. So angle PBN equals angle PAX. And you should see where I'm going with this. That's alternate segment theorem. because that is now equal to that angle there. Okay, so when we look at those two triangles, we have angle PAX equals angle PAN. Okay, because both of those equaled angle angle PBN. Okay, we also know that AP is common to both of those triangles, that one there. Okay, we know that angle ANP equals angle AXP, which is 90 degrees. Okay, so we've got two angles and a side. So therefore, triangle PAX is congruent to triangle PAN, and that is due to AAS. Two angles and a side. And as we started with, we knew that if we could prove those two triangles, then PX equals PN. So therefore, PX equals PN, corresponding sides of congruent triangles. And that is our proof done. Okay, now let's look at the exact same question done with our chord on the other side of O, so closer to Q. Okay, so there was nothing saying where our AB was. Before I drew it closer to P, let's draw it closer to Q. So we still have that perpendicular from P down to that tangent. We'll label that X. And we're trying to show that PX equals PN. So required to prove PX equals PN. Okay, now again, if we think about this, if we draw the line PA, we have our two triangles. If we can prove these two triangles are congruent, so what we want to be able to show, we need to show that triangle PXA is congruent to triangle PNA, because then we can show that those sides are equal. So that's our goal. Start with your goal. So now let's go back, and we started with let X be point where perpendicular from P meets tangent at 8. Okay, let O be the center. And we joined PX and PA. Okay. Now let's go back and go, well, what can we do here? Where can we go? The first time, use what you know. Draw in the radiuses because you know that they're equal. So join OA and OB. You know that OA equals OB because they're radii. We also know that ON is common. We also have that angle ONA equals angle ONB, which is 90 degrees. Okay, so now we have the hypotenuse, a side, and the right angle. So triangle ONA is congruent to triangle OBA, and that's because of right hypotenuse side. If they're the same, then we also know that this side here has to equal that side there. So therefore, AN has to equal BN because they're corresponding sides of congruent triangles. Okay, now let's look at our big triangles. So triangle PAN and triangle PBN. If we look at those two triangles, we know that PN is common, this side here. We've already proven that AN equals BN. And we know that angle PNA equals angle PNB, which is 90 degrees. So now we have side, angle, side. So therefore, triangle PAN is congruent to triangle PBN because of side, angle, side. Okay, so we could therefore say, therefore, angle PAN has to equal angle, PBN. So angle PAN, this angle here, has to equal PBN, which is that angle there. Okay. Now let's go back to the triangle we want to work with, our PXA. Angle PBN, the one that we just found was equal to PAN, has to equal angle PAX. This one here. Okay, so I'll highlight it so you can see that that's the alternate segment theorem. Okay, so that also corresponds to that angle in triangle PAN. So therefore, angle PAX has to equal angle PAN because they both equal angle PBN. Okay. We also have a common side here. So PA is common. And we also have a right angle. So angle PXA equals angle PNA, which is 90 degrees. Okay, so what do we have? We have the side is the same, and we have the two right angles, and we have these two angles here. So we have two angles and a side. So therefore, triangle PXA is congruent to triangle PNA, and that's because of AAS. So therefore, PX has to equal PN because they're corresponding sides of congruent triangles. And that is our proof. So as you can see, 2 questions done in different ways to get exactly the same outcome.